All right, this is my very short introduction to how to use silverdecisions.pl for decision trees. First thing I always like to do is go in here and I switch this from currency to decimal. The default is currency, so that way we're not seeing dollar signs when it really doesn't make any sense because we're talking about utility. When it actually comes to building out decision trees, I like to actually put it in cluster mode rather than tree mode. It defaults to tree mode, but I think it looks better in cluster mode. I'll show you the difference in a minute. So as we move forward, we're going to be building out the decision tree for the party problem, which is sort of a classic, simple example of decision theory application. And I find that in this software, it makes the most sense to go from left to right first, and then go top to bottom. In other words, build out one entire root to leaf branch, and then fill out the rest of the tree. And the reason this makes sense is that you can take advantage of copy pasting this way. So I'll show you what I mean here. So we make our first decision node, which is the party problem, the party decision node. And then we add directly to this. So we right click on that node and we say we're going to add a chance node. And the chance node is the will it rain question, rain question mark. And then we're going to add to the rain question, we're going to add two terminal nodes, which are the two outcomes. We're going to say one of them is it will rain, one of them is it will not rain. And as we can see here on the left, we don't even need to click off of this chance node because the two edges have just popped up here. So for the top edge, we will say, yeah, it does rain. For the bottom one, no rain. We're going to change the probability for the top one to 30% that it does rain. And then as you can see, you leave this number sign here and it automatically calculates whatever it makes sense for that number to be when possible. So see, it's populated this number with 70%. Okay, so that's nice. We're not going to populate the payoffs yet because that's going to depend on the full structure of the tree. Okay, so we've made this so far, so now we can take advantage of copy pasting. I copy all of this and Control C. Now that I've selected it, I click on the party decision. I Control V, paste. Click on the party decision again, Control V, paste. Okay, and then I click on the party decision node again, and I can see, okay, we have these three branches. We're going to label the three branches according to the party problem. The decision is, are we going to do it outdoors? Are we going to do it on the porch? Or are we going to do it indoors? And wherever you're leaving things default value, they're probably going to be calculated for you in a minute. So we go back over here, and this is where we assign our outcome utilities. So remember, one of the important things about the process is we score our outcome utilities and then we assign them here. So here we would say, our payoff for if we're outdoors and it rains, this is the worst situation, so the payoff is 0. If we're outdoors and it doesn't rain, that's the best situation, so we're going to score that at 100. If we're on the porch, again, I click here on the chance node so I can see everything quickly. If we're on the porch and it rains, we'll call that a 40 payoff because maybe people are getting wet and they're uncomfortable. But if it doesn't rain, well, that's like a 70 because at least you're getting some sun, but hey, you're kind of cramped in on the porch, so it's not great, right? So that's kind of how we're expressing this as being a middling favorable option. And then we go down here to the indoors option, and we say, well, this is the least favorable in an overall sense, but it doesn't really matter if it rains or not. So we'll just say that it's like 50 if it does rain, 50 if it doesn't rain. And again, these are all subjective numbers. It's totally like up to the actual person undergoing this decision when they're evaluating their relative utility values. These could all be quite different depending on you and your preferences. And the software actually just sort of goes ahead and solves the problem for us. It chooses the branch with the highest expected value. So the 70 here reflects this 70 here, which is telling us, hey, if there's only a 30% chance of rain, given these outcome utilities, that is the best choice. The best choice is to have your party outdoors. Now we can do kind of a quick and dirty sensitivity analysis where we say, well, what if I actually thought that it was 90 utility to go out on the porch if it doesn't rain. What consequence does that have? Okay, well, that actually changes the decision. It says now we should go out on the porch because by increasing the favorability of this specific leaf node, it actually increases the expected value of this choice, and now the correct choice is to go out on the porch. The nice thing about this application overall is that the copy pasting does allow you to do some pretty cool things pretty quickly. So I'll show you an example. So very quickly I can show you that I can add a decision node, which is going to just sort of pop down here nicely. And this decision node is going to be our value of information calculation, and we're going to call this the oracle node, or we're going to call this this is the oracle node. And the question is, do we pay the oracle for the information or not? And so the assumption in a value of information calculation is always under the assumption of you just buy exactly the certainty that you want. So you're going to pay the oracle an amount of money, and the oracle is going to tell you to a certainty whether it's going to rain or not. So of course that's sort of the idealized limit. In reality, what you're usually doing is you're paying a bit of money or a bit of time or a bit of resources for a little bit more information than what you had before. And you can model that too, obviously, but it's usually productive for me anyway to think in terms of the limiting case of the best you could possibly do by purchasing that information. So we say the oracle case is there, and then we are going to copy the entire tree. Did I just copy that? So I just selected the entire tree, and I copy, Control C, and I go down here and I click on the oracle and I paste. And so one nice thing about the cluster view is that it makes everything line up vertically. I'll show you what I mean in a second. So we're going to add here again. We're going to take advantage of what I've done here. We're going to add a chance node in here. We're going to add a chance node right here. So you can inject a chance node into an existing branch, right? So we're adding a chance node there, and so this upper branch is the we do pay the oracle branch, pay the oracle, and the lower branch is no oracle. So what I mean by that is we go to this lower branch, we say no oracle. Well, that's just exactly the same tree that we just made because nothing has changed. And then the upper branch, we pay the oracle, and now I'm going to copy this whole tree again. I'm going to copy the whole tree again. I'm zoomed in, so it's a little tricky. I'm going to paste it right there. So now we've got oracle rain, and what I mean by that is on one branch the oracle says it rains. Oracle says it rains, and on one branch the oracle says it doesn't rain. So on the oracle says that it rains branch, we're going to go through and we're going to change all of the places where we say that the probability of rain is 30% to 1. And it's pretty quick to do that because this isn't a very complicated tree. I think one limitation with pretty much all software is going to be there is no silver bullet to just saying like, do I have to type it so many times? This is actually not so bad. You only have to type it 3 times. You could, of course, if you were using a spreadsheet, you could link all these where this is equal to this is equal to this. And I do that sometimes to just save myself a little bit of clicking. Here, I don't think we have that option. There may be a way to define variables, but I don't know. Anyway, then we go down to Oracle says it doesn't rain. We click on this. We say, well, we know it doesn't rain, so the probability of rain is 0. Okay, probability of rain is 0. Okay, probability of rain is 0. Great. All right, I'm going to zoom out a bit, even though the resolution might not be great, just to see everything that we're looking at in one go. And basically what's happening is we are getting a sense of whether we should bother paying the Oracle for the information or not. And currently, the calculation is actually. Oh yeah, sorry, I forgot something. I forgot to say that the odds that the oracle says that it's going to rain, as far as you know, are just whatever your prior probability was. You don't know any better because you haven't actually paid them anything yet. So you're going to say, well, I thought it was 30% likely that it was going to rain, so now I'm going to say it's 30% likely that the oracle is going to say that it's going to rain, right? And so what that tells us is the value of paying of employing the oracle is 85. The expected value of just making your decision without paying the oracle is 75. So it's a better choice to employ the oracle. And what, generally in life, you actually have to decide if you're going to actually buy the information. So it tells you that the difference in utility, 75 versus 85, that's 10 utility difference. That's how much you should be willing to pay, 10 utility equivalent in whatever resources you're thinking about. That's how much you should be able to pay at most for the information of whether or not it's going to rain. Because obviously, if you know it's going to rain, then you can just immediately decide where you're going to hold your party and hold it in the most optimum location and avoid the negative outcomes, such as holding it indoors and then realizing that, hey, it was a lovely day outside, or holding it outdoors and then it rains. So obviously there are a lot of other things that this thing can do. There are all sorts of options here in terms of calculating the what shows up over here. So you switch from max to min, and it's showing like the worst outcome. I'm sure there's some reason you would want to know that. Like if you just want to see like, well, what's the worst decision? And let's say you had multiple decisions, then that could be useful. But for now, this is all we're going to focus on. We might dig into more details later.